Hi, welcome to the second day of the Delphi Bootcamp. Today we will focus on the Delphi language, the programming language behind Delphi, also known as Object Pascal. The information is at the link that you can see on the screen, 2016 Delphi Camp Day 2. And my name is Marco Cantu, and here you can see my email address. And further contact information, Marco Cantu on Twitter, and my blog is blog.marcocantu.com, and it's also mirrored on community.embarcadero.com. The Delphi product manager at Embarcadero Technologies, and I'm a long-time Delphi books author, conference speaker, guru, expert of the language and the technology around it. So today we are going to focus on the language. Yesterday, David I did an introduction to the IDE and the core architecture. Today, we'll really focus exclusively on the language. And the idea will be to try to start really from the basics and compare the core Pascal and today's modern Object Pascal with other programming languages. So rather than trying to focus on each and every feature, because that will take days, I'm just mostly trying to compare and contrast with how other languages implement similar features, or at least underline what are the differences, peculiarities, and specifics of Delphi and Object Pascal. And again, the focus will be trying to understand why Delphi is what it is, why it matters, why it's a great programming language to use. And of course, the other thing that I'm going to touch on to is some of the most modern language features, specifically anonymous methods, but also generics and reflection. All of the demos are linked from the main page, but you can also reach them directly on GitHub. Might do further updates today, tomorrow, the next few days, if anything comes up that's worth my attention. So let's start with the Delphi language today. And again, you can call it Delphi language, you can call it Object Pascal. Today's modern Object Pascal is quite different from the old-timers Object Pascal, which is in turn different from the old Turbo Pascal and other Pascal languages, although there is a heritage that actually it's quite significant. The fact that you can compile some very old code written even before object-oriented programming exists and Windows existed into today's modern multi-target operating system is actually quite a significant element of the overall language and its evolution. But the language is keeps changing and keeps getting more modern features and becoming available on more operating systems and platforms. It is a very popular language among the 12, 15 most common languages for many, many years now, and still there. Currently, Delphi and RStudio ship with from 1 to 6 Object compilers, depending on the version. The Starter edition only has the Win32 compiler. There is a Win64 one, there's one for iOS 10, and the second one, which is technically for the iOS simulator. And then there are 2 compilers for iOS and Android that are based on the LLVM architecture. Actually, there are 2 compilers for iOS, so it's actually 7 compilers, because iOS is available both for 32-bit and 64-bit. So we could spend a lot of time on the history of the language, how we got there, but I'm just jotting down 4 dates. 83 is when Turbo Pascal started. It's kind of the foundation of Pascal as a widespread language. 95 is the year that Delphi as a language was introduced. So modern the beginning of Object Pascal as we know it today, from Borland and then Embarcadero, which evolved later, and the most important year is 2009, with the introduction of features like generics, anonymous methods, and reflection that we're going to focus on later on. Now there's another date that's important, 2013, because that's where Object Pascal moved outside of the desktop to the mobile world. Now, going back to the second day, 95, the thing I wanted to point out is that's an interesting year. It's the year that a number of programming languages became public. Not only Delphi, but Java, JavaScript, PHP, and Ruby. And that's quite interesting because I often hear things like, oh, Object Pascal is old. I mean, not like JavaScript, not like Ruby, not like PHP, not like Java. And it's exactly as old as any of those 4 languages. So all of these languages have 20 years on their back, which doesn't mean they're good or bad. It means that they have gone through some interactions, they are certainly mature, they are robust, they might or might not, depending on the language, provide lots of backwards compatibility, but they're all relevant languages in today's landscape. So as I was mentioning, you can find actually way more than what I can cover in this webinar in the handbook, the Object Pascal handbook. It's over 500 pages. You can download the PDF with the starter edition, that's free. So they're both free this week. It's available on print if you want to buy, have the big tome, the printed version. Amazon has it on most international locations besides Amazon.com. So having done this introduction, let's start from square one, from the real basics of the language. And yeah, I know that some of you listening would have like years and years of expertise with it, but this webinar is not meant only for the expert, it's meant for everyone. So I'm really trying to start from the basics. Now, it might be that even the experts can learn a few tricks here and there. What I'm going to do is, I have slides, but I'm going to spend the minimum amount of time on slides and really spend most of the time writing code, looking at existing demos in the Delphi IDE. So the first point is, that's quite of a specific feature of Object Pascal, specifically compared to the curly brace languages, C, C++, Java, JavaScript, and C# and others. It's the fact that it's readable. The structure is readable. The fact you have to type begin end rather than braces, it takes a few extra keystrokes, but ends up being pretty handy and pretty nice in terms of overall readability. The fact that operators are called and or not, mod for module, rather than some sequence of symbols can really makes the source code extremely readable, more English than anything else. Or even some of the statements, the fact that you write a for loop clearly indicating where it starts, where it ends, and you don't have to stop thinking about the different elements of your within your parentheses. That's really, again, a point of clarity and understanding. Now, there is another thing that's part of the readability that's more related with the code structure, and we'll get to it in a second, and it is the way that code is written within a single file. There are languages that are really strict in that everything you declare you have to immediately implement. There are other languages that are extremely loose, like C or C++. You need to make that information available to the linker somehow, but the way you structure the code in terms of files is completely free. Object Pascal has a very specific approach, which is using units, and the fact that these units have a structure. And again, we'll get to that in a second, because what we really need to start doing is to start writing and looking at code by creating a small console application. Now, forget about some of these things that are written here if you don't know about them. The main point here, here's where we want to write our code. And the simplest thing you can write is just write something out. So we just say hello bootcamp and get to see if this really works. If I don't stop the program somehow, for example, asking it to read. So this is our hello, and it's a very simple application. It's really absolutely trivial. Let me save it just for the sake of future references. I'm going to call it console 101 and save it within the folder structure that I'm going to share on GitHub. Very simple, and you can see the structure of the code is included within a begin and end statement. This is a very particular one. The program is like the main part of the application. It's something you generally don't touch, as we'll see in a second for visual applications. In this case, it's our starting point because this is a console application. And here we can just write a bunch of statements or call functions or declare variables and use those variables. Again, as I was saying, you generally don't write all of this code in the main program file, but you use secondary files. So let me actually add a new unit. This is a secondary module, and just call it unit 1 for the sake of the demo. The interface portion of the units is where you declare some things to be available. Let me create a very simple procedure and call it hello. And this is what the module makes available. And this is how it is actually written. And I'll just going to be lazy and copy my message from here to here. And then now what I'm going to do in the main program is call my hello procedure, which is like a function. For other languages, just a procedure is a function without a return value. So now I have a more structured application where the bulk of my code resides in this unit, and the main program just has the core structure or core architecture. It's not a different behavior, not a different type of code, but we've started going towards having a little bit of structure. Now, let's look at the structure of this unit. A unit has a name. Interface is the first part of the unit. And basically, it's a list of data types, procedures, functions, variables, and other features of this unit that you want to make available to other units and to the main program. Everything that's written in the implementation portion, including variables, types, and other declarations, is local only, something you can use only locally within this unit. So the difference is that these units have the .pass extension, while the program have a Delphi project extension or DPR extension. The program has two roles. One has the startup code, and the other has the list of everything that's part of the application. Units define unique namespaces, so the same symbol, the same hello procedure could exist in two different units. It's generally a very bad idea, but technically it does work. So you can actually prefix the symbol with the name of the unit it comes from, like this. Again, not really needed and not a standard coding style, but it's technically possible. Units can have a dot notation, not something we need to focus right now. They enforce visibility constraints and have this visibility in these areas. The other thing that's critical is that units are fundamental for the power and the compilation speed in Object Pascal. Now, first, and I haven't mentioned it yet, but it's absolutely critical to underline, all of the code you write in Delphi is compiled, regardless of the platform. It's compiled to the assembly code. ARM assembly, Intel assembly, whatever. So this compilation works by compiling separate modules, like other languages do, but in a specific way. When you're compiling a unit, the unit gets compiled into a DCU file, a Delphi compiled unit, and this file has both the binary, like an OBJ file for C language or others, but it also has the meta information. So whenever another unit refers to that unit, it doesn't need to recompile header files or include files or anything like that. But the DCU has already the images for the compiler symbols that are needed. That makes compiling units that refer to other units extremely fast, because the units need to be compiled only once, the definitions need to be compiled only once, and then they're cached, actually not in the DCO files themselves, but in memory for even better performance. Now what happens when you compile the project file is that the project file has the information for the linker to say, hey, this is all of the units that need to be put together. Of course, also the units included by these units and so on and so on recursively will be added into the application as needed. That of course becomes a little more complex when you're using large libraries. In this case, the code is extremely simple. As we'll see in a second, as we go for a visual application, when you're creating an executable, there are basically two options. One is you can build everything into the executable itself, like it happens for a console application, or you can build it with runtime packages. This means that you have a set of DLLs, technically they're called BPL, Borland Package Libraries. You have this set of DLLs that you have to distribute along with your application. But that's an option you have. That will make distributing change to your executable smaller, because you generally don't change the compiled packages, the runtime environment much. But the thing I want to underline here is that by default, the opposite happens. So by default, everything you get and compiled into your application gets in a single exe file. That makes it extremely simple to distribute Delphi applications. There is no runtime to distribute. There is no runtime library needed on the system. There is no dependency or a virtual executor environment like .NET or Java. I go creating very simple multi-device application, and that's going to be a one button app. So it's going to be a form with one button. Now this is my button. Let's click the button. Let's just write the simplest code I can here, which is just a show message. And again, hello bootcamp. This is good to go. Now we'll get to the structure in a second. Let me compile this and run this. We have our button, we have our message, and this works fine. Now the code architecture here is a little more difficult and a little more complex, but if we open the source code for the project, we still have a project. We still have a program. There are a couple of different files listed here, and then there is our unit. So the unit that has user interface form. The initial code is almost always something similar to this. There's a bunch of forms that are created at the beginning, and then there is a run method that's the loop for the application to keep executing over time. Where you write the code is in your unit. Now this is a combination of a visual designer that determines the layout of your user interface, at least at the beginning, because you can of course customize it at runtime in code with no designer if you want to, and we'll get to some of it later. Behind this file, which is a graphic file, the same name of the unit with the FMX extension, or DFM for a VCL application, you have a form class that inherits from a base form. Now this might be familiar to you, might be very surprising. We get to inheritance and forms and the fact that forms are classes a little later on. Where do you write the code is in event handlers. What is an event handler? Hey, wait a second, we'll get there. But let's just consider for now that you can write code fragments behind your buttons. And so you can have one or more of these form classes throughout the application, and they're all combined together into an executable. Again, each unit is compiled. There are tens, dozens, hundreds of library units that are compiled and included into your application, and eventually your application will execute and run. This is very fast to compile and to execute, but if we go for project information, we'll tell you a few things about the compiled code. This is also in debug mode, so it's actually a bigger application. This is some of the information. And notice we're not using runtime packages. So this is a single executable application that what it happens creates a Win32 folder with a debug subfolder, and this is your executable with full debug information. That's all you need to copy around to move this application over. Now it looks big, but again, it embeds a large amount of library code. An alternative option, what I was mentioning earlier, is you can decide that you don't want to keep shipping into each of your application all of these runtime packages. So you can actually say, hey, I want to link With runtime packages, you can provide a list of packages. So now we can compile this application with runtime packages. We do a build, and if we look at the project information again, we see that the application is extremely small, but it requires two fairly large runtime packages, runtime library and FireMonkey. Now again, if we look into open this in Explorer, Win32 debug, you can see this is really small, but it's not self-contained. So you can pick either one or the other. There's no difference in the way you write the code. You can just move from runtime packages to having a single monolithic application as you prefer. This is one way to create commands, as you can see, curly braces. Another way is to use double slash, like C or curly brace languages. Another thing that's absolutely important to consider is that the language in itself is not case sensitive. So you can type show message with the S and M lowercase. This is still going to compile work also at runtime. There's no runtime check. Everything is checked at the design time. So let me start delving into some of the real meat of the language. The first is that everything is in a type, and everything is a type, and types are the foundation. Object Pascal is strongly typed and type safe, with very limited exceptions. There are ways around it on purpose that you're generally strongly advised not to use unless you know what you're doing. But in itself, the language is very rigorous in the type check. There's a reach-based type system, not just the standard reach-based type system with numeric values, characters, strings, floating point values, booleans, but actually there are some distinct and specific features that are part of the type system. We'll get in a second to looking at what's exactly an ordinal type and what are enumeration sets. So let's start delving into the type system a little more. And to do that, I'm going to open a group of projects that are part of the first part of the demos that we're going to look into today. So the starting point will be looking at this integer type, and specifically using the integer type to go onto and over ordinal functions. What's an ordinal type? An ordinal type is a type that has an order, meaning a sequence. In an ordinal type, you can increase a value and get to the next one. Like floating points don't have a next value because it's logically undefined. But an integer or an unsigned integer of this size have the concept of next value. And you can get that using increase. You can also pass a second parameter, which is increased by 10, or by 10 position, or by the numeric value of 10. In this case, the two things technically match. Types have also a concept of high and low, so the lowest possible value. And let's actually run this and see what it does side by side here. Oh, oops. Yeah, sure. There is an error, but the error is actually by design because I've increased the value by high, which is the largest possible representation, and by doing so I've gone into an overflow scenario. Now what's important is that this overflow scenario is not an absolute thing, but it's something you might want to check that you have enabled in the compiler options, specifically the runtime check. There is overflow checking, there is range checking, there is input output checking. The reason these are not always compulsory is that, well, they take time, but it's generally a good safety net to keep all of these runtime checks enabled. Now I'm going to comment this operation that was faulty, although we can as well, and we can stop and re-execute. And now let's look at the rest of the code. So low is 0 because this is an assigned value. Increasing, we get to 1. Increasing by 10, we get to 11. And yes, 11 is odd. The other thing that this demo highlights is the fact that in modern Object Pascal, you can use helpers, which is a way to extend existing classes, as we'll see later, that can also be applied to some of the intrinsic data types. These intrinsic helpers provide ways, for example, to take a number and call toString to get it converted. Or you can apply to a constant like 33 to string. Size is another helper operation, which is the number of bytes used to store the value. And so here we are grabbing the size of the integer type and converting the size to a string, and so we get out the that information, and that's going to happen if I click on the first button. So 1033 and size of integer is 4. There are other things important for an ordinal type, including the ability to go along the values, for example, in a for loop. And we'll get to for loops later, but well, here is one. So this for loop goes from space to, this is the numeric representation of space. This is just any value. We can make, for example, this simpler, say we can go from A to Z, but then I'll restore the original code. So any ordinal type support for loops. So here we're just looping on the ordinal type from A to Z. And here also increasing the value of this ordinal type. So not only numbers are ordinal types, but also characters and other types are ordinal in the language. Okay, and then we can restore back the original code that was here, and we can execute it again, and this time we get a much longer set of values that goes over down here. That's the Unicode alphabet. That's because the character is actually a 2-byte Unicode 16 character representation. Again, we have the ability to use specific helpers, character to upper or isLetter. These are all done with full Unicode support. Now, the other element of the type system is user-defined data types. And so let's look into this shortly. Here there are different data type definitions, and the keyword to do that is just type. So this is a range. This is a set of values from 1 to 10. This is a subset, actually not of integer, probably of byte, but that's not the important point here. And this can only represent numbers from 1 to 10. So if you try to assign 12 to this value, what would you expect? I mean, will this work? Will this just ignore it and do it anyway? Will it fail at runtime? No, not exactly. It does not fail at runtime. It fails in compile time. The compile time, this violates these subrange bounds because this is a constant. So it's easy to figure out, hey, this is not legal. In other cases, the check, if you have range checking enabled, the check will be done at runtime. So again, this means this T10 can only get values from 1 to 10. Uppercase is another subset of the char. Enumerations are first-class citizen in the language. They are also ordinal types, so you can say that increasing clubs you get diamonds, increasing diamonds you get hearts, and so on. And then you can only assign these values. You cannot assign a numeric value to an enumeration, although there are conversion functions. You can assign the second element of the enumeration to the enumeration with a conversion. And finally, a set of can be, you can imagine is like a set of bits where each flag is on and off. So it's 1, 0, 1 or more of these items, and only once each at most. So in this case, diamond spade, meaning I have club is not enabled, diamond is, heart is not enabled, and spade is. But and there are specific operations like include, exclude to add or remove items from the set. Basic statements. It's not that I'm going to spend much time on this. Assignment is colon equals, and not only equal. Equal is for the equality operate test. Separation of statement is with the semicolon. It's not a terminator, it's a separator. It makes a difference only in a few specific cases. There are if then else statements. There are case of statements with multiple branches. There are for loops, traditional for loops, as we've seen. There is also a for in loop, kind of a for each in other languages. And there are while and repeat loops that I'm not even going to show with specific demos. So let's just look at the code shortly. This is a very simple if statement. Notice there's no parentheses needed if you only have one expression. You start introducing parentheses when you have an and of multiple expressions. And again, and is written and is fairly readable. So in this case, there are nested if statements, and one of them has two operation with and also here. This is another common approach, which is if then else if, kind of nesting, but literally putting them like all on the same level. And let's go for a for loop. This is a standard for loop for I equals 1 to 10. There's also a down to loop. You can count reverse, so you can count from 10 down to 1. It would basically, in this case, get the same value. In other cases, the sequence will be different, so you'll get a different effect. There's no step operation, so you can say count by 2 or anything like that. So let's run this for loop. This is my for loop, and it just totals these numbers. The second one is a loop that goes from A to Z and shows each of the characters. Similarly, you can do a for loop from the first to the last value of a string, from the lowest to the highest element of a string, and go over them, hello space world. But in this case, what you really want to use a for in loop for each character in the string, show the value. And again, it's the same exact result here that we just had above. So the for in loop can be used on few native types like sets, strings, but there is a way to define a for in for each user-defined type, records, classes, and many others, and many of the system classes, all of the container classes, and many others define their own for in enumeration. So the loop can be applied actually to a pretty large number of data types. Functions or procedures, the difference is only if there is or not a return value. By definition in Pascal, a function is called function only if it has a return value. If not, it's called a procedure. The fact that there are two keywords is a bit odd at the beginning, but it's not terribly difficult to get used to. Global functions are still supported. You'll generally use methods, which are functions associated with classes, as you probably know. But global functions in itself are part of the language even today. And both types of functions, globals and methods, offer overloading, offer default parameters, have an open array parameters, the ability to have an undefined number of parameters. They provide support for nested functions, and they have inlining, which can significantly improve performance. How you define a result of a function is by using the result special keyword or the function name, or as a bonus for C language programmers, using exit and passing a return value, which is kind of using return statement. So let me show you a couple of short demos around functions, specifically an example of overloaded function. So here there are a bunch of global functions. Show message. This is an overload, and so I can have another show message as long as the parameters are different, and a third one as long as parameters are again different. And here is another add function that is overloaded, has the parameters with the reverse sequence. This is another function, new message with overload, and this also has default values. So you can omit the last value, and you can omit two values because they have default value specified into the declaration. So you can call them without those extra parameters. Only one or two or three parameters calls. Again, there are lots of details around here that I really don't have time to delve into. More data types. Dynamic arrays are cornerstone, although traditional static arrays are still supported today. Records, or equivalent to structures, have a lot of extended features. They can have methods, but only non-virtual methods. They support operators, overloading. You have a lot of control on the physical layout, but that's not something I'm going to touch on too. And they use a traditional memory allocation system, which is one of the main differences with classes. The other is the ability or not to have inheritance. Other data types is string type. It's an extremely efficient Unicode type. And yeah, the language even has got pointers. So let's try to go through some demos of these features. This is a very simple example of record. This is a record with methods. So nothing too surprising here, but it is a bit. Again, functions or procedures that are associated and can access to the local data directly. And the fact that you have methods and data is generally combined with the fact that some of the data can be private, so I have limited accessibility to the outside code, while of course the local methods can access private fields. And public, meaning this is something that can be used from the outside. Okay, here is there's a simple method declaration, just doing something and calling one of the methods. Here is another very simple sample, creating a record, assigning some values, and then calling a method on the record. Notice when you're calling a function on the record is copied. So if you want to get a result, you can assign to the resulting value and then grab the result of the function call. The other option is to pass the parameter by reference and be able to modify the parameter directly in code. Now, this is a big difference because objects in Object Pascal always behave like references. So records and objects have a different memory structure, memory layout, and memory behavior that is quite important to have a good idea of. Again, these are the methods of the record. They can just access the local data. And what else is important here? I'd say that mostly what I wanted to show. Let me spend a little extra moment on this other type example. This is a point record with operators. There is an add operator. An add operator is defined with this syntax, class operator add, but when you invoke it, you end up invoke it by just calling plus. So using the symbol, it's defined with the extended name of the operator, but it's of course invoked only using the operator. So a plus b adds these two records, but how comes I can assign this numeric value to a record that should be incompatible? Well, it's actually not, because here I've defined one other very important operator, which is called implicit, which allows you to do an implicit data type conversion. It's a data type conversion that you don't have to spell out with a typecast. but it's done automatically, like it happens here. This converts an integer to a record. Here at the opposite, I've used an explicit operation to convert a record to a string, and so I must use the string cast to convert to ask for converting the string back, the record into a string, and then display it. Again, very simple output here. I'm going to press my button and add 1010 to 30, so it's 40 40 10. And why it's 40 20? The reason is that when I'm doing an implicit conversion, the y is set actually to 10, not to 0. So that's why we get the extra value in the result. Couple of very short demos about strings. Strings are extremely powerful, but also very smooth to use. So in most cases, you can just ignore any complication around strings and just use them. There's an extensive number of helpers and strings, like index of, substring, copy, and what else? Well, toString is the opposite conversion. So you can just use this version, this newer version of the methods. There are also global functions in the traditional Turbo Pascal and Delphi RTL to perform most string operations. But again, there are some pretty nice ones that you can start using today. Index of gets the position of a substring in a string, substring extracts the substring, length is the number of elements in the string, and replaces a value with another value within a string. So these are already easy to use functions. Some of these functions return a string, so you can actually change them with a fluent interface. Strings are dynamically allocated automatically, so there's not much you have to do and worry about. They are reference counted, meaning that when you have multiple references to the string, they're not copied. When you say string 1 equals string 2, but it's just a reference count. When all references go out of scope, the actual memory is freed and made available. The mechanism this uses is called copy and write, because when you end up, if you have two references to the same string, if you change one of them, actually there is a copy because you're not affecting both strings. And this copy and write operation is extremely efficient in the language, as I can partially demonstrate by perusing to this string metadata operation. So what happens when this program starts, there's actually some other code here on create. I have a string that is hello. It's created in this odd way for reasons that are too complex here to explain. You will never write a code like this, but there are reasons to do it when you want to look at the low level. And then there is a second string that is assigned to the first one. Now, if I press this button too, what happens is that I'm getting some status information on the string, namely the memory address, the length, and the reference count. And the same I'm doing for the second string. Then I'm changing one of the two strings, and what you'll see is that at this point there's a full copy of string 1, of string 2 to string 1 actually, and then the second string is modified. If we run the program, you can see that my string 1 and my string 2 are in fact the same string. They are at the same memory address, and the reference count is 2 because there are two references to the same string. As I do the change of one of the elements, there is a copy happening and my string is moved to a new different memory location, and both have a reference count of 1 because now they're separate, and of course, yeah, one of them is also different. Now there's a lot of extra metadata you can get about a string, element size, Unicode page, and other information, but again, that's way more detail that I want to cover here, and is fully part of the book. Just the syntax of pointers. Yeah, we have pointers. This is the only part of the language is not really readable, but it's probably good because you don't want to mess up with pointers too much unless you know what you are doing. So I'm not really going to explain too much of what's happening here. Just it's possible you can go low level in memory, more or less like the C language, in terms of pointer usage, but you tried not to do it. Okay, so that's the first part on the core language features and data types. Now let's move to the Object Pascal foundation, the object-oriented foundations of the language. Now let's move to the object-oriented programming foundations of Delphi, and the language has a complete object-oriented programming that was true since day one, since 1995, with classes, inheritance, static and dynamic methods. Later came the support for interfaces, and it is a complete language. It has lots of similarities with Java, has even more similarities with C#, with the two languages share the same designers, Anders Heilsberg. And although there is a big difference that the code in Delphi is completely compiled and there's no runtime support or execution environment like C# and Java require. So on one side it behaves more like C++ in terms of being compiled, but in terms of language and the object model is extremely similar to Java and C#. For example, the object reference model is basically the same. Now there's another area of the language that's integral part of the object-oriented programming model, but it's not shared with as in the same way to some of these other tools, which is the support for the rapid application development paradigm, the support for properties, events, the support for publish interfaces, for streaming, for class references, for virtual constructors. I'm going to show some of these features, although not everything in detail, because these are some of the cornerstones that kind of highlight the difference between Object Pascal and other languages in the same family as part of the same model. So let's actually start looking into some of the features, and again then move to the more significant, more relevant differences to other object-oriented languages. The fact that versatile method require override, that's the same as C#. The property abstraction is implemented differently because it can be mapped to fields or to read-write methods. The presence of named and virtual constructors is pretty unique compared to other languages. And shared features are sealed classes, final methods, nested types. And then another very specific thing is class helper. So we're going to go over all of this. And let's start with looking into a very simple class. Again, there's not much to say here. There is a class, there are two overloaded constructors, same name, create, but create is only a name. The fact is constructor is what's relevant. Again, we can have multiple constructors. I could have called this create new because it's just a procedure name, although create is by far the most common. You can have, again, overloaded method. You can have functions, which are method returning values, or procedures, which are method not returning values. So the implementation here is pretty trivial. I'm not going to get too much of the details. of how you write a class. But that's the idea. In the implementation is a date time, which is an internal floating point to represent dates and times. So that's the simple code, and yeah, I think I can run it, but it doesn't show much. It just goes today, can set the date and other things. Now when you have, this is another class and shows the structures and constructors and resource management. So this class has a reference to the other class. Now given the class has a reference to the class, and Delphi hasn't got a garbage collector, you have well, to create the object of this specific, the nested object in the constructor, but also have to write a destructor and remember to free that object from memory, or you'll have a memory leak. This is not required for components and other objects that are managed automatically. There are many cases, but in general, I mean, there is some concern that you have to keep onto the memory management because it's not all automated. The advantage is that it's fully under your control, so you know exactly when memory is allocated and made available compared to garbage collected languages. And also there's no background thread or other operations like this. But anyway, so that's model. And again, when you're creating an object, you create the object, you use the object, you free the objects, generally with a try finally block, but that's a separate issue. What else? Actually not much for this demo. Now the important thing is that, yeah, here we just created an object and use the object. But as you actually can figure out, when you are creating a form, the form is a class, or even an inherited class. So for example, and it's not an object. So when you're creating a form, you're not defining one specific form. We are generating a class of forms, which means that if you create two of these forms, and you use, you track the mouse down to count the clicks, each of your instances will have its own private field and its own click counts, and getClicks just returns the number of clicks and shows it in a label. So if we run the application, you can click on this form, yeah, the count increases, but then we can create a new form, and each of them has its own field, its own local data, because there are two separate instances of the same form class. That's important when you're creating form. When you're dropping a button on a form, you're creating a specific instance, a specific object. But when you're creating a new form, you're creating a class of forms. Now, of course, beside classes, there is inheritance. You can create a new class that inherits from a given class, in this case new date, that just changed the behavior of the getText function. It overrides it because getText was not virtual. If you want to have more dynamic behavior and use polymorphism, then you have to create the original class as virtual and the replacement version as override. Exactly the same two keywords used in C#. Virtual is not default, unlike Java, and it has to be asked specifically. And again, when you're modifying a virtual function, you need to use the override keyword. This basically keeps everything the same, but just change the this specific display of the date when you are creating an instance of the new class. So nothing special. I'm not going to focus much on it. Virtual functions support polymorphism and late binding, exactly like in most other languages. One feature that's a bit specific is the presence of helpers. What's a class helper? And there are also record helpers and other types of helpers. A helper is extension to a class that adds some methods to the local instances. So when you're using a local instance, you can use, in this case, item index value, the string currently selected in the list box. Or in this case, we can add we can have an add method to our memo component and change the behavior. Okay, so rather than inheriting a class and adding a feature, we're just creating a helper and extending the class. With local instances, you'll be able to grab your list box and just say item index value for the list box to get the text of the selected item. Sorry. To get the text of the selected item and, well, add it to the memo. Okay, so again, helpers are powerful, although they do have limitations, like only one helper can be active for each class and the last wins. And the helpers are also defined for records and also for, as I mentioned earlier, for intrinsic types. So helpers are specific features. Properties are also a very specific feature. Properties are generally seen as a way to extend components, but in this case, I've extended the previous click demo and added a clicks property. A property, as I was mentioning, can be mapped to fields, like in this case, the private field, or to methods, setters and getters. And of course, the parameter has to be compatible, or it won't compile. setClicks just goes changing the value and has a side effect of updating the status text, which is another property that describes the text of the click status. And basically remaps the content of label in a more abstract way. The properties are an abstraction that is absolutely critical to the Pascal language and to the designers, because what you see here in the object inspector are the published properties that can be recognized and listed at runtime. Here we do have actually a form running as to grab the properties of the form, and as you put a component like a label, you get the properties of the label. So the entire RAD model, rapid application development, is based heavily on the properties and other languages extensions. One of the properties, a specific type of properties are properties that have that are actually references to methods, and these look fairly complex, but these are what is called an event. So what happens when you have a button and you handle the onClick event of the button? Actually, what you're doing is you are assigning to the onClick property, which is basically a reference to a method, and the IDE basically just creates a new method as part of the hosting form, and the method is assigned to the onClick. Now, the same behavior you can do in code. For example, here, when I press the button, I change the behavior of the same event handler, button test of onClick, and assign another method. So what's happening here, if I select the application and run it, is that first time I have my test message, and second time I have a new event handler. Now, in this case, it's just a slightly different string. I could have used an if statement or whatever, but in fact, what's happening, I'm replacing the event handler with a new event handler in code. Now, of course, I can do something similar in terms of assigning an event handler also to an object that I create dynamically. This is the code you need, the minimum code you need to dynamically create a new button in the application when I click on the form outside of the other button. And then these buttons get behavior, which is the event handler. So I'm assigning properties to buttons, and I'm assigning an event handler to the button themselves. So that's important because I was saying, yeah, I mean, the design time capability are great, the ability to easily create the UI and attach behavior is fundamental, but everything you do at design time, you can do in code. There's really no limitation. Well, what you cannot do runtime is compile the application. The source code needs to be compiled, but everything you do in terms of manipulating the components, visual, non-visual components of your application, that can be fully done in code. Another feature that's tied to that is the concept of class reference. What's a class reference? A class reference is just data type that hosts a class. It's kind of a meta class. So in this case, for example, I have tControl class, which I've defined as class of tControl, which is an existing class of the system. And then I have a local variable control type of type tControl class. So in this variable, I'm not storing an object. I'm storing a class for the object. And what's happened is, as I click on these radio buttons, when these radio buttons are selected, what I'm doing here, I'm saving a type, tButton, tRadio button, tEdit, as fControl type. So I'm just storing the type. Now I'm doing something quite odd here when I click on the form, which is create an object of that undefined type. Now this is possible because we have class references in the language, but the other key feature that is absolutely fundamental here, and most other programming language, object-oriented languages don't have actually, is the fact that this constructor is virtual. So I'm not calling a generic tControl.create here, but I'm calling tButton.create or tRadioButton.create. So I'm calling the specific constructor of the specific class and not a generic, high-level one. That's a fundamental feature that's absolutely critical, for example, for all the streaming and layout mechanism that's used in the system. And also saves you a lot of time because it basically implements class factory pattern in the language by using class references and virtual constructors. So let me show you this in code, but it's actually not so odd. I mean, radio, and now I'm creating radio buttons, edit, and now I'm creating edit boxes with this same piece of code. So that's some of the power of the language that's at the foundation of the RAD model in Delphi. Now let's move to something more interesting for the object-oriented purists, which is the ability to use interfaces. Not that I can really spend a lot of time on interfaces, honestly. Here are two interfaces that are defined, and there are two classes that implement the interface and also inherit from a base class that provides the boilerplate code for interface management, including type checking and add and release references behavior. Interfaces in Object Pascal are a bit odd. They're originally mapped after the COM IUnknown model and still have some remnants, like the fact that they need a UID to be fully functional. You can get those with a shortcut key. So they are slightly different than and less pure, if you want to say, than other languages, but they're also great in terms of Windows programming because you have full power of COM built into the programming language, which is not bad to have at all. So here in this case, I have these interfaces, Walker and Jumper, with methods. Of course, interfaces don't have any code behind them. The code is required when a class implements an interface. It must absolutely implement all of the methods of the interface. Interfaces can have properties that are mapped to methods because they can have fields, so they cannot be mapped to fields. Very simple user scenario, creating an object Here I'm just using the object as an object, so it's not terribly nice, but here I'm actually creating an interface, assigning a compatible object, an object that implements the interface to the interface, calling methods, and I don't have to free the object because interfaces are reference counted. Optionally, there are ways to disable them today, but they are interface counted. Now we can go for more details and more complex demos of interfaces. For example, here I took the same demo, expanded it a bit because we actually have multiple an object implementing multiple interfaces. This athlete implements both iWalker and iJumper. And the other option is the ability to use have an object that implements an interface and then basically remap the entire interface implementation onto this internal object. That's a rather strange mechanism, but it's extremely powerful because you can use interfaces and object composition without having to reiterate the same code over and over. Again, multiple interface references. When you're implementing multiple interfaces, you can have a conflict because you know what, both interfaces have the same walk method. You can rename one of the implementations locally, so you still have walk both on iWalker and iJumper, but then you have two different implementations. One is walk and one is walk1. So you can differentiate the implementation of the two methods that have the same name. Now, when you're calling them, depending when you assign the object to iWalker or iJumper, you're going to call walk for one or the other interfaces. And the implementation is not terribly interesting or nice, so I can even skip running the program. I prepared another couple of demos, but I'm going to skip them for now. Because I want to move to some of the most modern features of the Object Pascal language. So I'm going to skip the section and class methods and data. There are some peculiarities here as well, but nothing too complex to consider. We did cover interfaces and reference counting. I'm going to skip exception handling. It's a core foundation of the language, and there is a full chapter actually in the book on exception handling. So, but let's move to the most modern features in the Object Pascal language. So what's in modern Object Pascal and what do I imply with this name? It's support for some coding styles that go beyond classic object-oriented programming. Type parametric code based on generics, so the parameter is the type, and function parametric code using closures or anonymous methods, dynamic coding style, and even some runtime based code using reflection, and going towards aspect oriented programming using attributes and behaviors. So these are some of the features that I'm going to cover in this section. Oh, actually, I'm going to basically skip closures and keep them for the last and final part along with the parallel programming library. So generics. Generics are classes with type as parameter. So they're not really classes. They are classes that are not fully defined. They need to become classes before they can be compiled. They are mapped after .NET, but they fully resolve the compile time, which is significantly different from the .NET counterpart. There are generic types, generic interfaces, generic records, generic classes, interfaces, and records, and also the ability to have generic methods in non-generic classes. There are containers ready to use, and I'm going to show a couple. Like t-list of t. This is how you generally define the generics, similarly to most other languages. And again, when you're creating a generic class definition, it's not a class. You need to create an instance first, although you can shortcut the two in a single statement. So let me open another bunch of demos. That's going to be modern, and that's the new project group. I'm going to save everything I've done, and let's start with this extremely simple demo, just mostly syntax. So here there is generic type, just a pair with the key is a string and the value is of type T. So there is a generic field, a generic property mapped on the field, and a method with a generic parameter of the same type T. There's not much you can do when you don't know what T is, but whatever. This is just a placeholder, and these are implemented methods. Now, how you can use it? Well, in different ways, but what you can declare here, for example, let me start from here. This is type that is now specific because you say key value of integer. So now this is a specific type. Now it's fully defined. I create a variable of that type. And creating an object, compatible object, and now I can assign values to the object. Now I can assign 100, I can assign left, but I cannot assign a non-integer to the value because it's checked at compile time. However, if I create now a different variable of a different type, because it has component as the T, now I can assign sender, I can assign self, I cannot assign left. So if I try and I compile, I get a compiler error. And same here, if I try to assign left, I get a compiler error. So for each instance, you need to be the compiler checks that the parameter is used properly, that generic element is used properly once instantiated. In the form itself, I have another variable. This is at the form level. That's based on T button, which is a specific subset of components. So now I can assign only a button to the button. And there isn't much in this code that's worth looking into. Now a demo we can look into a bit more is this demo of string versus dictionary. Program is fairly simple. It can fill some lists in memory, 500 items, 500,000 items, and then it does some operations on this to list. The first is a generic string, is a simple string list. The other is a dictionary. Now the focus, one of the reasons for this demo is to show that dictionaries can be extremely more efficient than string list, but they're also type safe, which is another very nice reason. It's probably even more important here. So let's compare. So one is a string list. The other is a dictionary, which is the object dictionary mapping a string to an object. Now string list can host an object, but it has to be casted back and forth. Here you can declare specifically what object type is stored along with the key. When you are creating the list, the code looks very similar. When we are filling the list, the code looks very similar. One is add object to a string list, and the other add an item to a dictionary. So no big deal. But when you're extracting the information, in one case, you have to do a runtime cast as to the type my object to grab it back of the right type, and of course this could raise an exception if this is not compatible. On the other hand, the code that uses dictionary just gets the object straight much more easily and faster. But also there is no runtime check. I mean, because we could only add TMI so we can only extract objects of that type. So it's more type safe than using a string list or a generic or a list that's not of a generic type. Generic method, as I was mentioning, is another option. Again, this class is not a generic class, so you don't have to create an instance. You just create, I mean, you can create an instance, but the instance is not tied to a specific type. So what happens here, you need to indicate the type when you are calling the method. So here I'm saying, hey, I'm calling this with a string, and you know what, the type of the parameter needs to match the declare type. Okay, the good thing is that this can be inferred, so you can only say hello or 122 or button, and this is also going to work. Now, there's not much this can do not knowing the parameter. What it does, it extracts the type information of the parameter using something bordering the RTTI that I'm going to explain next. This gets string, gets integer, short integer. So there is actually a difference here from this call to this call, because 122 being a small number is considered a small integer rather than an integer because it's a constant. But again, the concept is somehow similar. These are calls you cannot do, mismatching the types. So yeah, I mean, I could have spent like hours on generics. This is really a short introduction, but honestly, in most cases they behave in ways that are similar to what you'd expect from other languages. RTTI, runtime information was already available in the language since the early days, but it's been greatly enhanced. Specifically, there is a unit called system.rtti that lets you easily interact with the RTTI system. For example, here, what I'm doing, I'm getting the type. This is actually an object that represents the type of a class, tButton, and I'm going to see if tButton has the toString method, and then what I can do is determine the parameters of this method and invoke the method passing the parameters. Or in a different case, I can get to the property by name, by string name, and get the value of the property for a specific object and show the value. So accessing properties, accessing fields, accessing methods with or without parameters, this can all be done dynamically in code, as long as there is public information available, which means this information is available for all fields and for public and published properties and methods by default. So this is reading the values. And so if I press the invoke button, executing the toString method, I get back the class name and the caption and the text value. But if I do show, I'm actually calling the show button, the show event that displays here directly. So I'm not basically like calling show here, but in code, and I'm getting back this hello string in the memo, because that was the effect of calling show for the form. So that's kind of the simple idea of RTTI. When you have RTTI enabled, you can basically have a list of types, this context record that can instantiate to call get types. This is the list of all types compiled into the application. And then we can go have a for loop and go through the types. And if it's an instance, so meaning if it's actually a class, display the qualified name. So these are a list of all of the classes that are compiled into the application, and there are quite a few. And for each of them, you can actually click one and get the list of the properties, methods, and fields. Not that I'm going to show you exactly all of the code here, but that's the concept. So there is a full navigation throughout all of the classes compiled into the application itself through the RTTI, the extended RTTI. So you can navigate what's in the code, but the other thing you can do is you can decorate specific elements with attributes. And attributes are just classes that you can define, inheriting from tcustom attribute. And once they're defined, you can put them in square brackets to decorate any symbol, a class, a method, or almost anything else. If the attribute has a parameter, you can pass the parameter when you define the attribute. It can also have a default value, so the parameter could also be omitted. Now, what's the advantage of decorating these symbols with attributes? I mean, there's nothing generated actually in the compiled code, but this information ends up into the RTTI. So for example, what I can do here when I call one is check, if the type of the current object in my class has attributes, and if the attribute is a value attribute, actually extract the value of the value attribute. So again, get attributes, give me the list of the attributes for a type, and then I can navigate. Similarly, I can get the type, get the list of the methods, and then check if any of the methods has a given attribute. This is just a helper function here that matches, it goes through the list of attributes looking for a specific one, because there can be more than one attribute for the method. So if I run the application, it's not terribly useful, but this is the attributes for the class that we can actually see here, simple and value 22. We can see that one method has the simple attribute, and both 1 and 2 have one attribute. And then we can also go back and do an invoke. And in this specific case, I'm invoking only methods that have the simple attribute. And okay, I'm going executing the equivalent of the first button. Now, there's a lot around attributes and the ability to create algorithms that change the behavior depending on the presence of an attribute and its value. What I'm going to show here is a kind of realistic example of attributes used to identify functions rather than using inheritance and using the same name, virtual and functions, and overriding them. What I have listed here is a name. There's an attribute say, hey, this has the description. This function returns a string with a description of the object, and this one returns an ID. So it's called getName, and it's also getName also in this other completely separate class that's also marked with the same description attribute. But to get the ID here, you call getStringCode, and here you call getID. Not that it matters, because you can write some general code that would go through the list of, this just creates a list of objects, fine. Now in this code, what I'm doing, I'm going through my list of objects, I'm checking if the object has the type, has the description attributes. If not, I'm just ignoring it. If it has, I'm going to go through the method, see if there is a method with the class description, and I'm ignoring it, with the description, and I'm invoking the method to read the description, and the ID, and I'm invoking the method to read the ID. So I'm reading the ID from this object, not depending on a method name, but exclusively depending on the attribute that's set to one of the method. Again, either getID or getStringCode. And if we actually run it, you see here I'm creating two objects of the two types, and I'm dynamically extracting the ID, which happens to be two different function names in the two different classes of this list. So again, it's code that's dynamic and flexible based on custom decorations with attributes. The other language extension I'm going to touch on next, which is anonymous methods, and with that I'll also shortly cover a couple of features of the parallel programming library. So anonymous methods, or closures as they call in other languages, they are some sort of type-safe method pointer types. So meaning you can assign a function pointer or method pointer, and you can keep that reference around and call it later. They have a specific syntax, what I tend to call inline declaration, but the other thing that's really specific and peculiar is the ability to capture the execution context, capture the status of variable at the definition time and make them available at runtime, which I know is fairly complex to understand without looking at some actual code. That's why we have some code here. And in this case, we have a form with a bunch of buttons to do various things. We have anonymous methods declared here. Anonymous method types are specific types. In this case, it's a procedure compared to a function with one single integer parameter and no return value. So how do I use it? In the most simple case, which is the first button, I just assign a procedure, piece of code, and then I can call it, and well, call it again. So if we run it, press the button, we have 22, and then same once more. Now let's move to something more interesting. Here I have a call twice. What is call twice? Call twice is a method, it's a global procedure which receives the anonymous method as parameter. That's very often the case. You pass anonymous method as parameters to other methods. And as the name implies, it calls the method, it receives also a value that is passed to the method, and then increases the value and calls the method again. So what's happening here? We are calling call twice, and the method we're doing is grabbing that number 48 and then 49 when it's increased, and do one into hex, display in hexadecimal format. Second time we're passing 100 and creating the square root, and then 101, and again doing the square root. So let's run it, and so we have 30, which is 48 hexadecimal 31, and then 10 and 10 plus point something, which is the square root of 101. Okay, fine, but not terribly thrilling, honestly. We can also have a local variable, and like a number. There's a local variable here, and use that local variable within the code. Now this starts looking a bit odd, because this local number is actually made available through this call twice method that knows nothing about it, just because it's passed here as parameter. So it makes this local variable available within this method, but still is within the same lifetime. Now where things start getting a bit weird is that we can store the anonymous method. This anonymous method is just a local property of the anonymous method type or the closure type. And so what I'm doing here is it's not executing this method, but just storing it. Now notice that a number is a local stack variable here, and I'm using it, initializing to 3 and then using it, increasing and displaying the value, whatever. Now when I press this other button, I'm just calling the anonymous method and passing 5 as parameter. Now if we go back to here, this is the code. So the parameter is increased, added to the number. So as a result, I'm calling store, and well, nothing happens because nothing is displayed at that point. But when I do call, I have my 3, which was surprisingly kept in memory because this variable went out of scope apparently, but it did not. And then I added 5 to it. And then I add another 5 and another 5 and another 5 and another 5. When I do press store again, I'm replacing and recapturing that variable again. So it gets set back to 8, 3, and then 8, and then 13, and so on. So that's the idea, although I could spend a little more time in some of the details. But that's the idea. They can capture the execution context and whatever variable or object. In fact, this memo is also captured, in all practical terms, by the anonymous method. Now, what can this be used for? Well, a lot of things. One case, which could be, maybe it's a little odd, but here I'm basically customizing my button, adding an anonymous method to the button. So there is a new property, it's called anonymous click, which, unlike the standard click, is an anonymous method. So what's happening here is that there are two operations. One is I have a button to assign the event handler. The event handler is just simple. Show message senders the button.text displays the text of the button. So, oh wait, sorry, the other demo. Let's run it. I assign it, I invoke it, and yeah, I'm just doing this senders button.text. Now that's something you can easily do with an event handler. But now here I'm doing something more different. I'm assigning a method that keeps a reference to the sender at the time of this event handler was clicked. So this sender is the local sender, but this sender, and this also, but this sender, a component reference, is kept around and then used here. So basically, I'm not only displaying the button that I'm pressing when I do the show message, but I'm also showing the name of the button that was pressed when I assigned the event handler before. So do and then do invoke. Button invoke was assigned by keepref, by pressing keep reference. So it's some data about context that was available, the sender that was available earlier, and again, it's like a local variable that's captured by the anonymous method. Now you might be wondering why this can become useful. It can become useful because it lets you create code that's parametric with code. As an example here, I have a pretty stupid is prime number that computes prime numbers, and I had a traditional implementation of a for loop for one that goes 1 to max, and if this is a prime number, I'm increasing the total, and I'm also keeping track of the time it takes. Okay, so it's my for loop, goes through, takes, well, a third of a second to get this up. Now what this parallel for button. Now what I'm doing here, I'm doing something different. I'm using a feature of the parallel library. For method of the parallel, there are a bunch of overloads. Let's me create a for loop that goes from 1 to max, from the initial value, final value. And for each loop iteration, I'm going to execute this anonymous method that has an integer, and not surprisingly, which is the, at that point, current value of the loop in the as parameter. So I'm just replacing the standard code here with the code within this anonymous method. Now, what I'm doing here is also using interlocked increment, because one of the parameters of the anonymous method is one of the features of this parallel loop is the ability to execute the loop in parallel, which means multi-core CPU. If we run the application, we can see that the for loop takes 378 milliseconds. The parallel version is significantly faster, but does exactly the same. The result is identical. This case is an easy example because the computing the value has nothing to do with computing like the previous or the following value, so they're completely independent, which is where it's easier to turn the code into parallel execution code. Beside the specific case of the parallel for loop, in general, the anonymous methods are great for threading or multi-threading. There is, for example, the ability in the Delphi runtime library to create an anonymous thread that is a thread based on an anonymous method, which is this code. And then the thread that I've just created here using the Fluent interface, I can say .start. So this creates an object, and this executes the start method of the new thread object. So creates and starts. The object now synchronizes, gets a little weird. Synchronizes needed when you want to synchronize with the UI from a background thread, but that's the idea. So we can, rather than having to create a derived thread class and replace their execute virtual function, we can just create an anonymous thread and provide the code to be executed within the thread itself. That's just one example. Another example is here. I want to do a get HTTP GET call, and I'm doing that within an anonymous thread again. Okay, so just mostly to show the syntax and the behavior, and then the last demo, which is going to be the last demo of the entire session, is a demo of the parallel library, showing both tasks and futures. What's a task? A task is conceptually similar to a thread. And again, you assign an anonymous method to the task. But the difference is that a thread, if you create 100 threads, you might overload the CPU because you didn't have as much cores to execute all of your threads. And the time it takes to do thread synchronization and thread balancing could be actually come to detriment to the performance. The concept of a task is that a task is a separate operation that will be eventually assigned to a thread, but the system can create a pool of threads, optimize that pool of thread depending on not just the CPU and the cores, but even the current load of the CPU, and assign the task to the available threads. And again, so it's a more abstract concept compared to a thread. In this case, the task is quite stupid. Waits 3 seconds and shows something on the screen. And so that's what I'm doing when I press button 1. Let's do it. Run this, press button 1, and I get a show message. Now the only difference compared to traditional show message is that I can do other stuff in between. It's not blocking me, and then it is when it shows. Now, an interesting thing of task is the ability to do abstract operations, to start a bunch of tasks, for example, and then I can, again, conceptually say, hey, now I need to wait for all tasks to be completed. So here I have a 3 seconds task and a 5 seconds task. Not going to take 8 seconds to execute these two because they will be executed in parallel. If we run it, we can see that we start these 2 operations, and at the end, when I'm all done, I can grab the total value, because trying to read the total value in between will make no sense until we have the everything has been calculated by the different tasks. A future is a variable with a task assigned to it to compute its value in the future. As an example, I have a wonderful compute something, which takes some time to compute a result. And I have my one value. One value is not an integer, but it's a future for an integer. It's actually an interface. It's a future for an integer. This means that I can assign a function to compute the future value, and of course has to be a function returning an integer, given this is an integer. And here I'm displaying the status of one value. Status meaning has been completed or is still pending. I have another value which I compute directly. This is just an integer. And now I'm also checking back the status of one value. And finally, I'm adding the 2 values. One value dot value is the actual value. And at this point, if the value has not been computed yet, it will be computed, because this result always succeeds with the actual total value of the 2. And then again, I check the status once more. Now, we don't know if the status here is that the future has been completed or not, because it depends on the execution times. They're probably the same because I'm doing the same operation, but so yeah, you can see here's waiting to run, but by the time I've computed something, this ended up being already executed in the background, and now this is my result. But of course here it has to be completed, because that's after I'm actually used the value of the future. Okay, so again, the future is a promise to get a value out of anonymous method returning that a value of that same type. And that's what I want to show about the programming library. Because spend way more time trying to, after all of this fairly long description of the language, which just only scratches the surface of what's in the language and in the book covering the language. I can certainly try to draw a few conclusions. Object Pascal is a great language, kept mostly secret, great for learning, picked by many teachers today, and we also have a great academic program that's just starting. It has an incredible power, right, compiled to the libraries that ship with the product and our superb database technologies. It fosters developer productivity and has preserved long-time investments, because 20 years old VCL code still mostly works today untouched, compared to having moved from Visual Basic to .NET, WinForms, Silverlight, WinRT, and some other libraries in between. It's used throughout the industry in many top-of-the-breed applications, award-winning applications, business apps that you might have never heard on but that move billions, or public applications with billions of users, like Skype for Windows being one of the most popular ones. you might not know, and most of the users of Delphi application don't know that application is written with Delphi, but it happens to be, and there's still lots of wonderful applications out there written for Windows or other platforms with Delphi. So let me reiterate a couple of words from the foreword of my book: power and simplicity, expressiveness, and readability. The language is great for learning and for professional development. These are some of the traits of today's modern Object Pascal, a language ready for the future with solid roots in the past, and kind of the one best developer secrets, which is time to reveal to everyone. And with that, we can open it for questions.
Okay, David I here, and welcome and thank you to everyone on both GoToWebinar's broadcast mode and also on YouTube and Facebook. There's been lots of different questions along the way, Marco, some about stylistic conventions or preferences for different programming languages. I think a few things just to sort of summarize some of that. Again, we put T in front of variable names usually to denote type. We put F in front of fields, mostly inside of the component library, just so it's easy to read and understand what's going on, but that is not required by the programming language. Some people were asking about how to match up begin and end, and now with the Castalia integration inside of the IDE, people should have seen the little red bracket lines between begin and ends as well. So there were a few things. There's some things that we're going to have to follow up with people on about reports about speed of doing certain things, either in the language and or with one type information. So some of that we can follow up. Marco, people were asking for where they can get the samples that you use. So I've been pointing people to your blog post for day 2 of the boot camp and look for resources there. Anything else to add about language and samples and some of the things that you showed?
Not much, but certainly a few things. The language demos, I pushed everything to the to GitHub, and there was a link in the slides, and there's a link in that page on the community site. It's just because it's handy, you can just download the zip file if you want, or you can just import the GitHub project. I might do some cleanups and improve something over the next few days, just because it's easy to do it with, rather than just providing a zip file and having to update the entire zip file. So the idea again is to just provide some updates over the next few days. There is also another GitHub repository that has the entire source code of the book. There's way more demos than those I was able to show. Some of them are the same, some of them are different. Like there's no parallel programming library in the book, and a few of the other demos are not actually in the book, but most of them are. So there's a lot of shared content.
Yeah, I also pointed. Oh, go ahead.
And again, the book has, of course, hours and hours and hours of material compared to the couple of hours I tried to shrink, a broad coverage of the language into, which wasn't easy. I could have used more time. But.
And I pointed people to Danny Wynn did a great Code Rage 9 session in Delphi on the parallel programming library. So that link is in the Q&A log, and let me put it over in the chat window as well. He's got the link to his source code, and he's got a link to the replay of his Code Rage 9 video. So that's in the Q&A log in the chat window. And again, for all of you, when you install and register the starter edition, then you can go and grab the ebook copy of Marco's Object Pascal Handbook, which covers the language, again, the language aspects. And so in that book, Marco, I know you've updated it for 10.1 Berlin. You cover interfaces and memory management and things of that kind. Yeah,
there are several areas that I just briefly touched onto or not even discussed in this webinar. One is memory management. There's a full chapter, and I kind of barely mentioned it. Also, exception handling is actually a fairly complex topic when you start delving into it, and there's another full chapter. I just showed like a 1-minute demo. And there are many other core areas, like also the management of arrays and dynamic arrays. There's way more about strings. And of course, there are lots of information about classes, inheritance, polymorphisms. Those I didn't discuss too much because honestly, the implementation you get in Delphi is so similar to like C#, Java, and other languages that I prefer to focus on things that are either different or peculiar to the language compared to other like standard or commonly used OOP languages.
And again, people, you need to be a registered customer to register the starter edition. Then you can use that Code Central link I put in the chat window and is in the Q&A log. That'll take you to the download of the PDF of the ebook version of the Object Pascal Handbook. If you want a printed edition because you want to carry it with you, read it on the planes, on trains, in the backyard or wherever, where's that available, Marco? Do they go to your website or?
It's published by CreateSpace. Well, it's not published by CreateSpace, but CreateSpace, I mean, it's good prices, but the shipping tends to be fairly expensive. So the best option to get it is through Amazon, either amazon.com, .de, .it, .co.uk. I mean, most of the Amazon outlets around the world have it and ship it locally, so it becomes, Amazon does discounts occasionally. It's something I totally don't control, so the price might change a bit. But yeah, it's the best shipping option. Or if you are, if you have like any of the Amazon Prime or similar subscriptions, you can get it shipped for free. So Amazon is generally the best way to get it. And they generally have it again available in Europe, for example, for like second-day shipping or same-day shipping.
Okay. There were some questions about why would you want to use a destructor. I think there was at least one question. If you do your own free and nil to ensure that objects are destroyed in your own code, why would you need a destructor?
The destructor, as I replied, the destructor is needed only if you have additional resources. The short demo I showed, there was a person object that had a date internal object, and so you may have to make sure that when you're destroying the person object, the date object inside gets also destroyed. So that's a case you want to use a constructor. When the object has a reference to a resource, I mean a memory, a file, database table, whatever, that you need to close, shut down, clean up, release from memory. If the object in itself has only its own memory, then there's no need to write a custom destructor. Just free the object and it goes away.
Yeah, when you were talking about unit namespaces or name scope, someone asked the question, why shouldn't you use the unit name dot variable or dot method or whatever in your code?
Ultimately, it's just a habit. I mean, technically you can do it or omit it. It doesn't make any difference. You still need the uses statement, something I haven't really covered, but there's a lot in the book about uses. I mean, it doesn't make any difference. I mean, I don't think the compiler really would go faster or slower. Of course, there's no runtime difference. For readability, it's up to you. If you prefer, I mean, clearly spelling out that a given class, a given type, a given function comes from a unit, sure, you can spell it out explicitly. But in most cases, this is not used.
Yep. Jim, I'm not monitoring what's happening over on YouTube or Facebook, so I'm wondering if there's any questions from over in that world. I'll keep scrolling.
We've been answering the questions on Facebook, or I'm sorry, on YouTube. There hasn't been a lot on Facebook, though. Actually, Marco's been over here answering them on YouTube as well.
Okay.
One comment I'll make about that the last thing you're addressing about as far as addressing identifiers with their full name. What I'll typically do is my best practice, and is if I have something I'm using a lot of things from a unit, then I don't do that. But if I have if there's like one call I'm making just from this one unit, then what I'll do is I'll put explicitly specify that, because that way I know where that's coming from. And or if it's a situation where I need to call it from a specific unit, maybe it's defined into different units. But then what I'll also do is up at the top where I declare the unit in the user statement, I'll put a comment next to it saying what I'm using from that unit. And that way, later when I go back to maintain the code, I can remember what's going on and say, oh yeah, that's right, I know why I'm doing this, or where this is coming from, or what this is in the users clause for. Otherwise, yeah, like Marco said, you don't need to, and so I don't usually provide the explicit information about where it's coming from.
Yeah, although there are cases where you actually need it. And so, yeah, in those cases, because there might be like an internal function that's overloaded by a Windows API function or something else. Now, if you don't put the explicit unit name in front of the symbol, then the last unit in the sequence of the user statement wins, which is not great, because you might like end up like moving your user statement and the code doesn't compile anymore because it's like wrong parameters or something. So in those cases, yeah, you might want to be very specific about the units that's providing the symbol.
Yeah, there's always unit aliases, but that even hides it further right up in the project options.
Yeah, that's mostly for backwards code compatibility than something I suggest like doing.
I mean, one thing I wanted to mention about the Delphi language, you mentioned, you can use VCL and the language going all the way back. Textbook Pascal programs, even going back to Jensen Wirth, I think the only thing really there was the block structured I/O. And I think originally in Turbo Pascal 1 it was close for a text file. Now it's close file. And assign was the Jensen and Wirth original Pascal, and it's a sign file in Turbo Pascal, and then and all of that is usable in Delphi as well. So if you've got old textbook Pascal code, most of it will just work and compile and run, which is really cool. So
yeah, absolutely. I mean, it might not be the best modern way of writing the code, but the fact that there is this huge backwards compatibility, it's actually very nice, both in terms of core language, but also a lot of the runtime libraries and other elements. So, for example, someone was asking me why should I use copy or use string.copy. I mean, copy's been around probably since Turbo Pascal days, so fine to use it. It does work. There's no drawback. But in general, I mean, trying to move to like the new intrinsic type helpers can help. I mean, specifically new people coming to the language better understand what's going on and find those symbols. So the fact that you type string dot and you see the list of the methods rather than, oh, what was the name of that function to do the operation. I mean, that's also quite handy.
Yeah, there have been some.
It's also really an option. I mean, you have plenty of options. Some people complain there are too many options, but it's hard to have too many options.
Yeah, I think there was some questions about mobile and ARM and so on. We're going to defer some of that till Friday. That's where we'll talk about the mobile world. I know there's the whole question about memory management on mobile devices using automatic reference counting or ARC. So come on Friday and there'll be discussions about mobile-specific things and migrating your FireMonkey apps to mobile and dealing with memory management and operating system APIs and so on. Here it was about the language, the core language itself. And I don't know, there were some questions along the way about using records versus objects versus classes, the keywords object, class, and record, and when to use which and what you can do. Is there any kind of high-level overview, Marco, about record versus object versus class these days?
Yeah, records became extremely powerful with inclusion of methods and operators overloading. So ultimately, it boils down to what you needed the data structure for. The advantage of records is that they're managed in terms of memory which if you're doing the right things means you can gain some performance. The fact you don't have to create and destroy records on the heap, but they're located dynamically locally on the stack or within the hosting object can really save a little time. So if you're a performance frenzy, I mean, records can save some nanoseconds here and there. And so they are good data structure. However, in general, they are much less flexible. They don't support polymorphisms. They don't support inheritance. They don't have the same flexibility and the same complete set of features that classes have. So ultimately, it's an option. I tend to use classes more than records in general. But at times, occasionally, again, when there are like specific performance reasons or other specific reasons for picking records, that could be an interesting option. In the book, there is actually a fairly long session also comparing and contrasting performance of different scenarios using classes and records and advantages and disadvantages of the two.
Okay, Jim or Marco or anyone, anything else at the language level? One I should say this. One I should mention is about enumerations and scoped enumerations. Marco, would you like to say a few words about the traditional enumerations from years before and now scoped enums?
The traditional enumerations are just pollute the global namespace, because if you have an enumeration like the one I was showing, like the sweets with hearts, diamonds, and so on, all of those symbols, the symbols for the enumerated value become global. Now, they can only be used in context of assigning a value to a variable of that enumerated type, but they end up like polluting the global namespace. Now, the workaround that is used, for example, throughout the VCL is to use prefixes. So you use like 2 or 3 letters at the beginning of the enumerated value to like separate the value. So you have I don't know, for border style, you have BS none, saying no border style. And BS is just the short name that refers, okay, this is none, and that's meant for border style, which is fine, is not really ideal. Now, in more recently in the language introduced scope enumerators, and the difference becomes that when you refer to the value, you prefix with the type name. You're not saying a prefixing with the unit name, but with the type name. So it would be something like border style.none compared to BS none as a global value. This makes much easier, much more understandable, doesn't pollute the global namespace, and it's the preferred way of if you're starting from scratch. The FireMonkey all moved to scoped enumerator, so that's what you get on the FireMonkey side, but for the VCL, there was just way too much code around to consider a similar shift in the library. But for your code, yeah, scope enumerations are recommended, and there's a compiler directive to enable them. It's called scoped enumerators, and you just turn it on with a compiler directive or at the project level.
Yep. Let's see. Alberto Cantu says thank you very much. So,
so there's also, I also saw a discussion on YouTube. They started like a thread of which software has been written in Delphi with kind of the usual suspects. Skype, Setup, Master, FL Studio, 1Password for Windows, and more. So there is, I mean, I just mentioned it shortly, and it's not really the focus on this session, but there's really a lot of software that has been written and is being written today with Delphi throughout the world and throughout all industries.
Oh, some very big systems with millions and millions of lines of code in Japan. Here in the U.S., what is it? Wide Orbit does radio and TV and cable operations, advertising management, and so on. They're using a load of Delphi. Millions and millions, tens of millions of lines of code. But I put a link in the chat window. The Delphi Wikia has a list of good quality applications built with Delphi. People do that. Roberto's asking for an Italian version of Object Pascal Handbook.
Yeah, and I got the same question for a Spanish version. It's mostly not up to me. I mean, I won't be able to pay a translator to translate the book, honestly. I mean, out of my pocket. But if there is an opportunity, someone interested, a publisher or someone independent, there's been translations in the past, actually been a full translation in Japanese that was sponsored by our Japanese office and sales team. So there are certainly opportunities through local resellers or
some about, you know, the depth and breadth of the language and comparisons to other languages. I think you summarized it really well, Marco, right near the end there for people about, you know, the power of the language and what you can do with it. And then that's not even counting them going out into what we're going to do the next several days is in building applications using components. You know, I always think of Delphi as Pascal plus Object Pascal plus interfaces plus components plus anonymous methods, generics, and on and on and on, you know, plus, operator overloading, all these kinds of things that you cover in your Object Pascal Handbook, which is free for everyone to download. I think some people were having some issues. Just keep trying to get to the Code Central to download the ebook zip file. There's other books on Delphi programming and doing application development. If you go to community.embarcadero.com, in the resources menu, you'll find a books menu item. And in that books menu item, there's links to all sorts of different books written about Delphi, including Marco Cantu's books in different spoken languages. Tomorrow, Jim is going to be working with Daniele Titi. He's got his, Delphi Cookbook, a second edition for FireMonkey. I think, am I getting that right? All about doing FireMonkey development. Tomorrow's is all about FireMonkey. Maybe some people have been asking about, well, C#, and what about C# versus using the Delphi language? Do you have any general thoughts about that, Marco?
It's actually covered, I mean, in details. There are lots of specific differences and features compared to C# in the book, more than I covered in the webinar. It's true that in the webinar I was using like more general comparison to curly brace language without going to the specifics. There are also similarities. There are features that C# brought along from Delphi, the fact that you declare virtual override, the fact that methods are static by default and not virtual like in Java. So there are lots of things in common. Now, C# has had a continuous evolution, has a lot of extremely advanced features, which are currently nice to have. I mean, we're actually looking forward to expand the language, but to me, that's only part of the power. I mean, if you add like 100 new language features, but the libraries, the ecosystem doesn't keep up as much, it's not the winning factor. It's an important factor. And again, something we want to improve on the language side. But like, for example, we have plans for nullable types and other features in the language. But again, it's part of an ecosystem. Honestly, I mean, it's difficult to compare languages to languages. You have to compare the overall. And there are things in the overall C# ecosystem which are great, but others that are really a little troublesome. Like if you want to build Windows applications for the desktop, it's really hard to pick the right combination of libraries and technologies, although this goes beyond the language again. The fact that Delphi supports Win32, WinRT, lots of different paradigms, and is fully cross-platform is great. Now C# has a way to get cross-platform, but the language has been designed to be executed in an execution environment. The fact that iOS prevents the execution environment is really not great. The good thing in Delphi is that the language is designed from the ground up to be compiled. That provides great performance on mobile and other platforms where performance is more complex to obtain than on the desktop. The fact that we're using ARC compared to a garbage collector, for example, is a very significant feature. So there are quite a few areas where, if not the language itself, the entire language ecosystem has Delphi really competing with C#.
Yeah, and I mentioned to people in the Q&A log, they were asking questions, things about like exception handling and so on. I mean, there's not enough time to cover everything. There's multiple levels of exception handling support in Delphi. There's the operating system exceptions, hardware exceptions, the runtime exceptions, then there's exceptions that can happen and exceptions that you can create your own exception classes and raise those exceptions as well. And Marco's book covers exceptions in detail. So if you want more about exception handling, you'll find it there. There was questions about...
The other thing that,
go ahead.
The other thing I want to mention, I mean, and I kind of pushed the idea a bit, like neglecting other areas like exception handling. They're really very similar to other languages. But the fact that, I mean, Delphi really makes creating visual applications very nice, although again, you can really write everything in code. But that's because the language is really geared towards that direction. The fact that, I mean, two features that I mentioned, like class references and virtual constructor, are features that that C# and Java don't have. And when it comes to building dynamic behaviors and streaming objects and things that are at the foundation of a visual development environment or a RAD tool, Delphi has the advantage of having specific language features in that direction. They might not sound so last fashion or such trendy as other language features, but they provide really a core foundation that's fundamental for the language and the ecosystem.
Yeah, and then there were questions about test-driven development and unit tests, and we have DUnit, DUnitX, and then I put the link to Stefan Glinke's Test Insight. Check that out, Test Insight. It's a plugin for the IDE that makes it real easy to use unit tests inside of the IDE for your application. So if you're, for those of you really into test-driven development, extreme programming and so on, then unit testing is fully supported with Delphi. So check out those links that I put in the Q&A log. There was questions about memory leak, and I put the link to the system call report memory leaks on shutdown because we use the FastMM memory manager in your applications. It has hooks for memory management and memory leak detection. There's also SmartBear Software's automated QA. There's Eureka Log. You can use CodeSight, which is an Embarcadero product, to track and log what's going on in your application. So there's lots of support for reporting, logging, and checking for things that happen during execution.
Yeah, absolutely, and specifically memory management. The thing that might come to a surprise, specifically to developers using C# or Java, is that memory management is open-ended. You can plug in a different memory manager in the system. You can do it at the global level. You can do it at a class level. You can have classes that allocate memory differently. I mean, in terms of where the bytes are taken from memory from other classes. So the interesting thing of Delphi is that, yeah, it has, I mean, in terms of language, the object model is really similar to C# and Java on one side. But on the other hand, you have most of the power you have in C++, where it can really go down to the metal in many areas. The fact that there are still pointers floating around you can use, the fact that there are really low-level capabilities like fully customizing memory management, is really a testament to the fact that it allows you to go deeper in at the raw metal, something that languages with a virtual execution environment generally don't provide. You have to stick more with the rules that the language offers.
Yeah, there was a question along the way about what component was used for your list of types. I don't know if you were using a T-list. There's all sorts of lists and string lists.
I think that was a T-list on display on the main form, and then there is, I don't remember the structure of the secondary form. I mean, I put in the question log a link to this specific page. If you go on GitHub/Marco Cantu, you can navigate, and the form files are actually text files. So even on a version control system, you can actually see the they're not written in Pascal. It's just a streaming system. It's not XML, but it's very easy to grab. It's just indented with objects, sub-objects, and similar structures. So it's very easy to have a look at one of these files and get an idea of the components that are used and their properties.
Yeah, I showed that yesterday. When you're in the form designer, just right mouse click and say show form as text. And then you can also then right mouse click and you can edit the text representation of the form streamed objects and properties. And then you can right mouse click and say view as form again, and all those changes you made in the text editor can go there. You can also use external tools, and as Marco mentioned, you can even have your forms text representation in a change management system. Somebody was asking what about crash analytics, and I pointed everybody to the app analytics. So we have a component T app analytics, which allows you to log uses, method entries, wherever you want to put the analytics to see what your users are doing with your applications. One of its features also is unhandled exceptions, so it can keep track of crashes and information about the crashes. So check out App Analytics and the T-App Analytics component that you just drop into your application. It talks through HTTPS to a server that we run. And so check out the App Analytics page. It's got pricing information and so on if you're interested in something like Twitter's Crashlytics or what was it, Criticism has another analytics system. There's many other ones out there as well.
Yeah, there are other add-on tools that let you capture the stack trace on exceptions and report it automatically to some of the most popular backtracking systems like Eureka-log and MadAccept.
Yeah, so for those that are wondering about Linux, check out Marco's article in August, the roadmap update, and also his recent Linux blog posts. You can just go to his blog on the community.embarcadero.com, look in the blogs menu, and you'll see Marco Cantu there. Marco talked about in an article our support for Linux that's being worked on, and gave you a sneak peek of a Linux console application showing how the ID can change the target platform to Linux and then can compile and link a Linux application and send it to a Linux target operating system. So you can check that out in his recent blog post about, I think it was done for the 25th birthday of Linux, I believe.
Yeah, the end of August.
Yep. Let's see. Marco, do you make the Object Pascal Handbook in any other EPUB format besides PDF?
No, it's only available as a PDF, just because I'm too lazy to figure out how to do a good export and in other formats. So it's PDF only, or you can buy it and get the paper, the good old paper version.
There you go.
It's on Amazon and other outlets.
Yep. Here's a question that just came in recently. Is it also possible in the future to assign a default value to a variable at declaration time? We don't do that like you can do in C where you say int x equals 20. I mean, you can do that with consts.
You can do that with a constant. You can do that with a global variable, although it's not that using global variables is a terribly good idea. But global variables support initialization. Local stack variables don't. It's something that's been discussed. I mean, it might happen in the future. I'm certainly not ruling it out. It would make sense to avoid having like separate initialization at the very first line in code, but only when you are initializing to a constant. Anything more complex would be out of scope. In expanding the language, there are many constraints that are considered. It's features for the features, but also anything that would slow down performance or go away from the current single pass compiler is considered negative, because that's where you get the unbelievable speed of compiling applications. I mean, again, you get native apps like in C++, but compilation time could be 1/10 of a C++ application. We have customers compiling like 30 million lines in a single executable, and it's not taking hours and hours. It's taking a relatively short amount of time.
Yeah, I know there's other things you didn't have time to cover up that are overloading multiple class helpers, I guess, is another one that some people look at. There was a question here, what about handling stacking of multiple class helpers or inheriting class helpers? Or
yeah, that's been an ongoing discussion about making class helpers more powerful. And some of the people in the team don't really want to go in that direction because class helpers were supposed to be kind of a hack or a limited feature, but not like a full-grown feature. So, but I fully understand the idea of expanding them to a full-blown feature. Now again, there are some complexity, for example, for the intrinsic type helpers, like the helpers to string, integer, char, and other types. You can create those, but again, that will replace the default ones. But ultimately, the ability is to go towards mechanisms for auto-boxing that would not that would make those helpers like go away and have like mechanism. A different mechanism going forward. So because it was always there were only doubts about some potential change to the model, they were never really made. But that's something that's also open on the table, and we are considering for the future.
Then there were questions about web development and web architecture. It's not the focus of this bootcamp because we're focusing on what's available in the starter edition, but we do have T-Web Broker and people use it all the time to build CGI apps and also ISAPI DLLs or Apache modules. We have DataSnap and our RAD server for doing REST JSON-based development and TCP and HTTP multi-tier development. There's cloud APIs, REST components. There's a whole bunch of things in the Pro and Enterprise editions beyond just what you see in the basics that we're covering here in the bootcamp this week. So you can download the feature matrix for Delphi from the Delphi product page. On the right-hand side column, there's a PDF download link, and you can see what's in each of the editions. For capabilities across the language, database, IDE, frameworks, runtime library, and so on. So check those things out. And if we don't provide a component or a library for it, TMS software, you know, and on and on and on. Developer Express. There's hundreds of third-party component partners of ours in our tech partner program. Go to tp.embarcadero.com. There's a directory there where you can search for types of components and tools. There's tens of thousands of components out there, both free, shareware, commercial, you name it. Some of those you'll find in the tools menu, Get It Package Manager, depending on the edition. I showed that yesterday, where there's open source components like the Turbo Power sets of open source components. So there's lots of resources across, across the internet in our partners and Delphi developers for probably just about anything you need. There's the whole JEDI project for JEDI VCL and JEDI component library, JCL, that gets you even more functionality. So there's a huge ecosystem. I think that's one of the big benefits surrounding Delphi when we were talking about comparison to other things. There's a very large component ecosystem because from the beginning, Delphi has the component model, which makes it very easy to create components and add components. Again, we could spend a whole week on component development. There is a component menu in the IDE where you can create a component using the component wizard, inherit from existing components, install components, and you can also do that through the Get It Package Manager. So I think, Marco, that's a lot. Again, the ebook really, for those that want to dig deeper into the language and programming, the ebook for Object Pascal Handbook is a great resource, plus the other books that are on the community books list. So, and of course, more to come always in the future releases. If you have feature suggestions, go to quality.embarcadero.com and either vote for others who've suggested features for the language, the library, the ID, and so on, or create a new feature request for something that you'd like to see, and then get the community members to support you in that effort. Any last words, Marco?
No, nothing in particular beside what I already covered. Delphi is a great language. There are lots of applications built with it. I know the question came again earlier. Skype for Windows is kind of a testament to Delphi, although Microsoft sooner or later will replace it with something else. But for now, it's still built with Delphi, even if it's been at Microsoft for quite some time now. But beside that, there are really a lot of applications. We also have a cool app contents that's been running for a few months for notable application written with Delphi and C++ Builder and either Windows libraries or FireMonkey. And we are finding, a lot of great apps that we didn't even know about. So the language is more spread out and used more widely than most people think. Just because it hasn't got all of the attention of the press doesn't mean that it's not used and not a great language. And again, we're starting new initiatives like this bootcamp and the Free Delphi Starter to go back spreading knowledge, information about the language, and of course, more than willing, if you like, this sessions and this week to give your friends the links to the replays. And always available to answer any question and to receive your suggestions about the language at marco.cantu as marco.cantu@embarcadero.com, or any other way you can reach me.
Yeah, we also have our Cool Apps contest. So if you've built some cool things, you can submit your cool apps. There's already been some winners. There's a winner each month of $2,000 towards any of our products. If you create a cool app, Jim McKeith runs that program and does blog posts about cool apps that have been submitted, and each month a panel of MVPs and employees vote for the winning cool app. I think, what was it? 1Password. 1Password is written in the Windows version, written in Delphi. It's a password management system, and it was one of the winners, I believe, recently. So I put some of those links in the chat window. There's the delphi.wikia.com. There's a Delphi wiki that has a link, good quality applications built with Delphi. Lists a bunch of great applications. The Cool Apps contest also is there. So with that, I will finish this. I will work on the replay, and I've put the playlist in the chat window. There's a playlist for Delphi Bootcamp. My replay from yesterday, my session is up there, and I'll get Marco's up there. The way it happens is there's the presentation, and then I append the Q&A from the 6 a.m. and 11 a.m. session on the end, and in the notes for the YouTube posting, I say where the live Q&A starts and where the formal presentation demonstration ends. So all that'll be there for each day, and then the links in each of the blog posts for each of the days. Marco has his GitHub link, and he'll put the link to the YouTube replay once I get it put up and get him the URL. So you can bookmark the channel and the playlist.
And one last thing, there were a couple of people having issues downloading the book. If you go to the link and you see an error, an overall error, you have to delete your embarcadero.com cookies, because if you haven't visited the site for some time, you might have some old cookies that crash the Code Central download. So just delete your embarcadero.com cookies and retry. It would generally fix that bug on Code Central.
Okay, everyone. Tomorrow is all about FireMonkey development. It's all the great capabilities in the FireMonkey framework for doing 2D and 3D application development. And so Jim McKeith and Danielle TT from our partner BitTime and author of a Delphi FireMonkey book, the Delphi FireMonkey Cookbook. I keep forgetting the name. It's really bad that I don't have that memorized by now. That'll be tomorrow at 6 a.m. and 11 a.m. Spread the word about the new URL to link in, and also we stream it on Facebook and on YouTube. So yeah, Delphi Cookbook by Danielle TT, second edition, covering all sorts of latest things to do how to do FireMonkey development. So tomorrow's FireMonkey, Thursday is game development using FireMonkey, and Friday is mobile development, how you can step up from the starter edition to the Pro Enterprise editions and do multi-platform mobile application development. So with that, we'll see you tomorrow.